Hey everybody, it's the 25th of September, 2024, and this is Plutus PBL Live Coding. We get together on Wednesdays at 14:30 UTC to build stuff. And we were going to start today with a little demo of, see you soon, Steve. We were going to start today with a little demo. Nelson's been playing around with UTxO RPC integrations. And did I just hear you say that it works?
Yeah, for basic transaction, but not everything.
Nice. Yeah, I'm so curious to see under the hood how that implementation looks, even for a basic transaction. That's really cool. So while you get that set up, for anybody who's not aware, UTxO RPC, you can Google it. There's a website. Um, is a collaborative project across the Cardano ecosystem where developers are building a shared spec for how applications can talk to each other, and then one language and one library at a time implementing that spec. So yeah, you can see it on Nelson's screen right here. And so you've been reviewing the spec and looking at how to implement it with Mesh.
Not exactly. I was just learning, yeah, UTxO RPC and RPC at the same time, and just trying to understand everything, using examples that these people have built, making examples. And while I was doing so, these guys started this project. So you can see that, oh, there's a new commit event. But you can see that it's like 2 weeks ago. While I was learning, they just created this repo. I just saw it. And then, okay, if they're doing it, I can do a similar one for mesh. I mean, yeah, I took a lot from their implementation and did from mesh. So Bless is another transaction builder. I forgot the team who is exactly involved there, but yeah, TX5 is also there. So
Yeah. Blaze is one of the core developers who picked up the Lucid project after Alessandro had too many things going on to fully maintain it. One of the devs there picked it up and has created Blaze as a more reliable fork moving forward.
that was the um, that was the anesthesia labs, right? And it's for
I don't
what was it?
know Micah's relationship with Anastasia. I probably knows those guys. I think he's full time. I gotta look that up. I think he's supported at IOG at this point.
Oh, my internet connection was breaking up. Sorry.
Yeah,
Am I audible now clearly?
yeah, we got you. Can you hear me?
Yeah, I can hear you
Oh,
now.
good. Okay.
Yeah, it was breaking up. So yeah, let's take a look at it without spending too much time into it. It shouldn't take long. I just uploaded it here and I haven't published it on NPM. So um, this is living in under the UTxO RPC, um, GitHub. So like it's under the team who's building UTxO RPC. So even though I'm just starting playing with my implementation, I think probably this will find a place either in mesh itself or under UTxO RPC. So we'll see how it goes, but I'm just playing around with it. So you can clone this, and I have it in my local repo here. So it's not published yet, so we're going to just use the local import. But what we're basically going to look at is this files and a lot less what I planned on showing a little implementation. But yeah, it's a small file, so we can start over here. So here is a small main function, and I'm just going to call it, and if it gets an error, we're going to console it, right? And here, like as usual, mesh, we know mesh. And what we usually do is we create a provider, and it's either Maestro or BlockFrost or Koyos or Opnius. We have a lot of implementation from the mesh who has, done the hard work of uh, the compatibility with those APIs. So here we're going to use another one called UTxO RPC provider, which I've implemented here locally in the source here. You can see the source code here, but this is not what we're going to demo right now. We're going to just see that it works and then talk a little bit about why it's exciting. UTxO RPC is exciting. So yeah, I created a provider like BlockFrost or Maestro or any other thing. Um, and yeah, let me just put in here. I have one running in one of the servers that I have running is 0051. Okay. Yeah, we're going to talk about this again. This is the exciting stuff, but let's just see that it works, right? So I'm not going, this is just a node. I'm going to run it using Node and not, web framework like Next.js or anything. So I'm just going to create a wallet. And this is the mesh app wallet. And I'm importing a wallet from the mnemonic. And this is the super secret mesh mnemonic that the mesh team uses for free trust. So I've created my wallet. I've loaded my wallet, and we have put in fetcher and submitter as the provider. Right? So this is where we're going to get the data. Okay. So yeah, we can see the change address of it, not required. But we can see that the provider works by actually, querying the UTxOs with the provider, await provider, fetch address UTxO, and we have the address, or the change address. Right. This will spit out the UTxOs held in this wallet. So I'm going to save this file. I have set it up so that I can compile it to JavaScript file. So run, and this does, what it does is the build TSC stuff that compiles TypeScript file to JavaScript file. So this is the JavaScript file of what we actually wrote. I'm just going to run this using a node. So, example and demo. And voila. So you can see that we are querying the UTxOs, and there are a lot because this is the demo wallet that the mesh team is actually using. I'm borrowing. So that's there. We can see that, we can start to see that it works. It's actually fetching it from the provider. And I have a server running at this port that we're going to talk about it in just a minute, which is the exciting part, I guess. Let's just use the high level, not the lower level one, but the high level mesh transaction builder, and just send a quick transaction. So this is the mesh high-level transaction builder that everyone has come to love about. And then I'm just sending 50 ADA to, this is a wallet that I hold. So let's see if we can build it. And here, the transaction is there. We're going to build it. And then I'm just going to console log the unsigned TX. Let's hide this one. And build, and then not run that thing again. So yeah, we have an unsigned transaction. In the next steps we can do is sign it using the same wallet and then submit it. But let's first talk about this before we do that. But like, at least I hope that everyone here understood everything that just happened right now. This is the mess thing that we have come to learn about. Learn and love using the PPBL, right? So no one has any questions with regards to this, right? This is simple mesh transaction building. If not, let's jump back to UTxO RPC and why it is exciting at least. So UTxO RPC is a standard that these guys are building. This DX5 Blink Lab, these guys are building a standard so that people can build an API that spit out blockchain information in the SWAMP format, so that people can use it, choose whichever tools they want to choose. And
so I could build a transaction with my Go backend, but then sign it with Mesh in my front end.
It's even higher than that. So let's talk about it. So we have servers, right? So right now we have 3 compatible UTxO RPC providers. One is Dolos, DX5. One is Not API by Blink Labs. And one is the RPC service itself from Dimiteren. All of them are in development. Not a single one of them is, ready for production. It's heavily in development, and that's exciting. But here's the thing, right? If you're going to choose other providers that follow their own standard, then what you're going to do is change this thing and use BlockFrost or Maestro, right? And under the hood, the mesh team has done, or everybody who supports this provider, an ATX building service, either in TypeScript, Go, whatever, has done the hard work of supporting those standards, or like whatever the schema that these providers provide, right? But we have these servers who support this standard. Now we can use any one of them, right? So we're not going to talk about how we're going to deploy this right at the moment, but I have right now in the moment a Dolo server running hosted in my port 0051, which is kind of the one we just looked at it. I also have a Cardano node API from Blink Labs running. This is some other high-level API, but 9090 in the port, I have the UTxO RPC running. And I have created a pre-prod UTxO RPC service in Demeter. Right? So now, what that means is this implementation is same for each of those servers, right? So you can use a service that's built by TX5. This one is Dolos. This one we just saw it worked. It just built the transaction. Let's do the Blink Labs Cardano node API. Now this is a known bug, so we're not going to see a happy result here. But this is a known bug, and I have raised this issue to the Blink Labs team. And yeah, they're working on it. So we're not going to see. Yeah. So they have a issue with how the address is deserializing, serializing or deserializing. There's a little bug there, so they're fixing it. But the point is, you can use that server too, or I I can use the one I have created in Demeter. This is the one. Yeah, in Demeter. Same thing. My keys, and it's not good to show this private keys to anyone, especially in a recording setting like this. I'm going to delete it, but yeah, it's just for the demo. And keep in mind not to show it to any other thing for your production app. So yeah, here we're going to see a good result. Voila. Yeah, let's just submit it to. Right, sign and submit. Why not? Signing the unsigned transaction, submitting it using our provider, and consoling log. Here we're going to use the Demeter. And we have a transaction ID that's in pre-production. So yeah, any questions? Do you guys understood the idea I talked about, the same implementation working for different services?
It's such a massively big deal, and the way you described it as being able to lean on that hard work that people have already done is, in my mind, a perfect description. Nice job.
Hey Nelson, I have a question.
Yeah.
How does this work with AI agents, or in the context of an AI agent?
In what regards?
So you are calling for a service, right?
Mhm.
So can AI agent just log into your RPC and select any of the service?
I mean, if they learn how to use the service, then they should, right? Like, if they learn the
Yeah.
standard, then they should, yeah. And yeah, exactly, yeah. I mean, when you bring in AI, I got a little bit confused, but we're going to talk about client implementation. So this exactly is a client implementation. And this client implementation can use any of those servers who are built
Yeah.
by different teams in different languages, actually.
Right, right.
Go one is written in Rust. Two of them are in Rust, I think. I don't know about the Demeter, probably Rust. But the big deal is that Maestro is built by the Maestro team, and they have their standard. And Mesh team, did the work and supported standard. Blockfrost has their Blockfrost standard, and here
Okay.
The Mesh team has implemented to support it. Here, UTxO RPC, yeah, we're going to support it using the UTxO RPC standard. But are we going to use the servers that are provided by one team? No, we can choose any of the servers that support this standard, whether it's written in Rust, whether it's written in Go, or TypeScript, or Python, anything.
Right.
So I think it's a big deal because, yeah.
I'm just learning about agents. So, I just thought that your agent could just hit one provider and you could go through Maestro, Blockforce, Coils, whatever.
Yeah. So I'm learning about the RPC stuff a little bit, and then how it supports different languages. And these guys have built some SDKs on this Node.js. This is obviously the one that we're using right now for the demo thing we just showed. We have the Python SDK, Go SDK, Rust SDK. You can use this to implement a client and use any of the servers. Python is, you have implemented a client, and Python. That doesn't mean that you can only use a server, implemented in Python by a certain team. You can use any of the servers, right? And yeah, so it's a standard and it's nice. So I guess that's the most of it, but maybe you can talk about now, should everyone use this instead of using BlockFrost or Maestro? The answer probably is no, because RPC communication, it's called remote procedure call. It's intrinsically different from REST APIs, which are used by Maestro and BlockFrost. These are probably more beginner friendly, or maybe like it's just more adopted. UTxO RPC is used in backend services, but it might have a little bit of learning curve and boilerplate stuff. So REST APIs, they're going to exist. It's easy way for anyone to jump in and fetch data. You need a little bit of setup for RPC, but here you're getting all this new upsides, I guess, pros. So I guess that's it from my side for now. Yeah.
Is this a Fund 13 proposal for us to implement UTxO RPC and Mesh?
I don't know, maybe.
But you've been really connecting just broadly with the concept of RPC. Any other like thoughts or insights to share on that journey?
Yeah, I haven't completely mastered it, so probably not. But one kind of I forgot the terminology they use it, but there's a thing called streaming that's supported in RPC. In REST, what you usually do is you send a request and the server gives you a response. That is available in RPC, but there's another thing called streaming. So you can actually create a request and then wait for the server to give you information. And one example of that is wait for, right? In wait for, what you do is you have submitted a transaction, that TX has. You give it to this endpoint for the RPC, and what it does is it tells you the different stages of the transaction, and as it does, the server will send the client that it is now in this state, it is now in this state. Where's the state? Yeah. So you do wait for this transaction ID, and the server will just not give you one response, but it will give you responses as the stages progresses, right? Transaction has been acknowledged by
Yeah, that's so much easier. Right. I mean, how much time have we spent thinking about how to handle, like we have the Maestro option basically of transaction state, but if it's just inherent in this, I didn't realize that was part of the spec. That's awesome. That's awesome. Oh yeah, that alone is worth it.
Yeah.
That's awesome. Cool.
So yeah, I'm going to stop sharing now.
What a fun session. Thanks, guys. I could share a 20-minute thing while we're here. 1 second to get in. So we just had the Chang Hard Fork, and now we're in the Conway era on mainnet. And as I think everybody's aware, some of the ways that transaction costs are calculated have changed. One of the most important ways they've changed is that now the size of the reference script you're using is accounted for in a different way than it was before. In parallel to that, the way we calculate or the way we evaluate redeemer costs, right, in terms of those X units and memory, or sorry, in terms of the budget and the memory, that's also changed. And so we have an application right here that's pretty important. This is the Treasury prototype that we've been using for a while here, and we've got real ADA locked up in it. And there's never been any like what's nice is that when transactions stop working in a front end like this, you still have all the on-chain stuff. So this app has been broken a couple times since the hard fork, but we've still been able to use it because we have working bash scripts, and that's all fine. But the reason it wasn't working is because script costs were not being calculated correctly. And so, talking to the Mesh team about this, Jingles and Hinson have been building all sorts of amazing stuff lately. And for a side project, I think just over the weekend, Hinson tweeted about this. He built this. Okay, so what do we have right here? This is an incredibly helpful public tool available at cloud.meshjs.dev. I'll drop this into the chat, but you can bet that we're going to be using this in a few different ways in courses, because I think this is a really important thing for people to understand. And what you can do here is you can take the CBOR hex of a transaction and paste it right here. And then you can provide an API key for either of these providers, Blockfrost or Maestro, on the network of your choice, and you can evaluate a transaction. So let me show you the transaction, or one of the transactions that's under the hood right here. Okay. And bear with me for just one more second. Now I got to open up the code base. And this one. So the two transactions that we use most often in the prototype are the one where somebody who holds a contributor token can make a commitment to a task that's listed. And then the one where somebody who holds a reviewer token can approve that commitment has been completed. And this is the way all of these transactions were initially built into this prototype. We're just using Maestro. Nelson was just showing us Maestro from a different angle, but here in Mesh, we can use our API key for Maestro, and we can use it as both a fetcher, a submitter, and an evaluator. Now, what does this mean? Well, Fetching gets us blockchain data, especially when in the transaction build, we don't provide everything. And I'll show you an example of that in just a second. Submitter is just access to another submit API. And then the evaluator is the thing that calculates the costs, as in that front end tool that I was just showing you. When we set up, and by the way, look, we're setting up a Mesh TX builder. Okay, so we're importing Mesh TX builder from Mesh. We're creating a new instance of it with these parameters, Maestro provider for all three, fetcher, submitter, evaluator. And then we're going to call it Mesh. So down below, when I use this Mesh variable, it's referring to this instance of a TX builder. So down here, I use it. We say, let's build an unsigned transaction. And on that Mesh instance, we're going to call a bunch of methods. We're going to add some collateral to the transaction, inputs to the transaction. We're going to spend from a couple different Pluta scripts, inputs from those validators, datum, redeemer, here's the reference input, and so on and so forth. But then we do this magical thing at the end where we just say complete. What does complete do? You can look at the docs. Complete builds the transaction and it queries the blockchain for any missing information. Missing information like what? And how does it work? Well, one example of missing information is the stuff that needs to be fetched. We give this Mesh instance a fetcher so that we can do things like this. We can specify a collateral or a UTxO input with just the TX hash and the output index. This is incredibly convenient. Any of you, Sarah, you were talking right before we went live today about using an older version of Mesh. There was a lot of stuff that was actually convenient about that. For example, you had to know more about a UTxO than just the TX hash and the output index. You had this UTxO object that had also the list of outputs in that transaction and the amount of assets that we will be including. When we deal with UTxOs this way, we don't have all of that information. We're just providing a TX hash and an index, but who holds that UTxO, right? What address is it locked at? What are the assets in that UTxO? We don't specify that here. That is part of what the fetcher does for us, okay? It gets that other information. But that's not the only kind of missing information this is talking about, okay? We query for missing information, sure. The other thing that we can query is the evaluation, the costs of running the scripts as specified in the redeemers of each of these. So check it out. This TXIN redeemer value, it takes the redeemer itself, which right here I've called that distribute redeemer. Distribute redeemer is defined above, and we're just building a redeemer that complies with our smart contracts. The type, Mesh now gives us a few different types. It can be mesh data, JSON, or CBOR. In this case, I'm writing it like JSON. Watch. Distribute redeemer. Let's go find that. Okay, distribute redeemer is defined up here. And if you're familiar with what on-chain datum and redeemer look like, this should look very familiar. And this is what the Mesh team means by JSON formatted datum or redeemer, right? It's just the JSON format that you might be familiar with if you use Cardano CLI, for example. So that's that. But it doesn't have to be that way. You could also still use the more like the the higher level abstracted mesh data types, or you could use a straight up CBOR string. And hopefully, as I'm showing you all of this, you're kind of seeing connections to what Nelson just demonstrated, but more on that later. Okay, so we've got our redeemer itself, we've got the type of that redeemer, but then we've got one more optional thing, which is the X units. And this is what has that memory and steps right here. Okay. Now, before the hard fork, this worked this way. We were able to build those redeemers, specify this format, not specify the X units. Why? Because those X units were going to be provided by the mesh provider, or sorry, the Maestro provider that would evaluate the transaction for us. And for some reason that we're still diagnosing, this didn't work anymore. And now let me show you an example. Okay, now I shouldn't say it didn't work anymore. It didn't work sometimes, which is even more frustrating, right? Nothing's more frustrating than something working sometimes, but not other times, and you can't figure out why. I'd rather something just be completely broken than work sometimes. But let me show you an example of this. And actually, I don't have any reviewer transactions ready to go, but I'm just going to show you, because of the limited time we have, a quick overview of how this thing works. And we can go deeper into the details later. Okay. So in the wallet that I have in this browser, I have a contributor token. What does that allow me to do? It allows me to commit to a project. And I put these test tasks on here when I was diagnosing this. We're going to erase these, and we're not going to actually make commitments to these. My only goal here is actually to build a commitment transaction, right? And let me open up my dev tools as well so we can see what happens when I do. When I build this transaction, my eternal wallet pops up so that I can sign it. I'm not going to sign it because I don't want it to succeed. Okay. But I'm printing to the console this CBOR string right here. Okay. Let me copy this. This is the string in question when we want to evaluate this transaction. This is a mainnet transaction. My provider is Maestro. And just to do things the right way, I'm going to go off screen for a second while I grab my Maestro API key. So give me a moment to copy that from over here. And then I'm going to paste it off screen for just a moment. And now I'm tapping the evaluate button. Oh, good. It's already obscured. That's perfect. It's a really good tool. All right, let's evaluate this transaction. Okay. This shows me that this transaction is not going to succeed. The evaluation result from the Maestro provider right here is greater than the actual amount that's being specified in our transaction build. It's too low. Now, in some cases, it's okay. The memory that we specify is actually a little greater than the amount required. But in all of these other cases, memory steps and steps down here, we don't have enough. Okay, we're evaluating in this case. Actually, that looks okay. Why is this red? Actual. Oh, right. No, this should actually be fine. Actual, we're just saying too much. Maybe this is turning red. I got to ask the team why this is red. seems to me that 489 million is more than 447. And let me back up something else. I glossed over this. The reason we have two of these is that we're unlocking from two different validators in the same transaction. Okay. So let's go look at that transaction for just a moment. What I've done in the current commitment transaction, as I'm diagnosing this problem, is I've commented out the evaluator part of Mesh TX Builder, right? Because in deployment, it's giving me this. I don't want this. And instead of, remember, we use that evaluator down here when we call complete. What does complete do? It queries the blockchain for missing information. It fills in the gaps in our transaction. What I'm doing here is no longer leaving that gap. I'm specifying explicitly memory and steps, memory and steps. If you've ever heard about evaluating a transaction and then padding the results, that's kind of what I'm doing right here. It's not ideal ever to hard code these values, because if you hard code them, it's very likely that one of these two things is going to be true. You're either going to hard code a number that's too small, and then your transaction is going to fail because it's not going to evaluate correctly. Or you're going to hard code a number that's too big, and you're going to pay more of a transaction fee than you wanted to, or than you had to. So it's absolutely the best to dynamically calculate these values. It's just that at this moment, what we used to be able to do dynamically is not working. And again, that's why having a tool like this is so important. Now, because we're at time, one thing I would love to do is show how to go back to making these, to calculating these values correctly on demand. But we're going to have to save that one for a future lesson or for next week's session if there's nothing else to do next week. But I just want people to be aware that if you see an error around transaction costs, and actually, by the way, let's do this to wrap up. Let me show you the error. I wasn't sure if these were going to be thumbs down in the red, so I didn't want to sign this transaction. But now that I know that these amounts are not enough, I actually have no problem signing this transaction, and I'll show you why. Let's do it again. Connect wallet, contributor dashboard, commitment TX. I'm going to sign. And this is really important to notice, right? This is a valid transaction. If the validator logic was bad, I wouldn't even be able to sign this thing. It would have already failed. Everything about this transaction is valid, except that when I sign it, I see, wait for it, this error. Okay. So this is the error that's showing me that something's going on. Invalid transaction submitted as valid or vice versa, et cetera, et cetera. It's a bit of a general error, especially this part. The transaction failed unexpectedly without exactly telling me why, right? This error message is only so helpful. But if anybody else is building and you encounter this error, I just want you to know that it has to do with improperly calculated X units. Okay. So yeah, let's pin this one. If there's time at live coding next week, I'll show you how to fix this error. And if there's not time during a live coding session, this is a great topic to demonstrate with the help of this new tool right here in an upcoming lesson. So we'll be sure to do that. But I hope at least seeing it from this angle is helpful. Any questions about that?
Hey, James, which development platform you use? It's not VS Code, right?
Oh,
Or-
I migrated to NeoVim a few months ago because I had heard enough about it that I was ready to learn it. And actually, I'm never going back for personal development. It's sped up a lot of things that I need to do. All right. Cool. We had a demo from Sarah. We had a demo from Nelson. I just shared a little demo. Um, that's a really nice little live coding session right there. We have a lot to do updating Plutus PBL, and we have a lot to do building some upcoming courses that all connect. And we're going to focus on that in asynchronous work, but this topic will come back to us every Wednesday at Live Coding, and also even in the Gimbalabs governance sessions on Thursday. I want to continue to align plans on all the courses we're building because we've got Plutus PBL to update. We've got Mesh PBL live and continuing to evolve. We've got the Cardano Go PBL course that has a beautiful outline and some really nice examples, but we've got some lessons to flesh out. And over the next few months, we will launch Aiken and Marlowe PBL courses as well. All of these will connect to each other, right? So if you're learning one part of the development stack, like a lot of you have already seen in Plutus PBL, we might introduce a little bit about Mesh, but then link you over to the Mesh course. And we're going to keep following that pattern in all of the courses we build so that we have this cohesive constellation of different chances for people to learn things and to see how it's all connected. So lots of exciting work ahead. Keep building examples and keep it up. See everybody soon. This is great. Till next time.
Okay.
Cheers, everybody.
Yes. Take care. Bye.
Bye.